This is a problem where we have to look at an area between two functions. With problems like these, we must show all our working out. In addition, solutions relying on calculator technology are not acceptable. Now please note that this area R is bounded by the x-axis, which is y is equal to 0. It's also part of a curve, which is given to you over here by y is equal to x minus 2, x minus 3 over 4 root x, for all values greater than 0. And you'll notice that the curve cuts the x-axis when y is equal to 0. These 2 points over here. This means that the numerator must be 0, and therefore x minus 2, x minus 4 is equal to 0. So our solution to this would be that x is equal to 2 or x is equal to 4. This means that it cuts the x-axis at 2 and at 4. This will be 2 and 4. So the area R is bounded by the x-axis, which we said was y is equal to 0, and we'll call it the upper boundary. And the lower boundary is the y of the function itself. X minus 2, x minus 4 over 4 root x. So if yu is 0 and the lower boundary is that function, therefore the area will be equal to the integral of the upper function minus the lower function dx. And most importantly, we need to know the boundaries. They are from 2 to 4. Now we'll substitute the functions. And so now the 0 really becomes irrelevant, and we'll put the minus outside. So I'll put the minus outside and do it in green, so that we can now do the integral of 2 to 4 of our function x minus 2, x minus 4, and so on. And the next step is to realize that integrating in this form is not possible. So what we need to do is to expand this whole thing. And this becomes x squared minus 6x plus 8 over 4x, and I'll put it to the power of a half. Now we need to distribute that denominator to with every term in the numerator. And we have 3 terms. And I've separated all the terms, but I must embrace them with this brace here and include the dx. Now I will need to simplify everything. And once again, I'll brace it and dx. So we got so far to the stage where now we can start integrating this. And this is called a definite integral. We do not need to put a constant of integration because we're doing it in a boundary between 2 and 4. Now we don't need to use the integral sign anymore, but we just need to use a square brackets. So we start integrating the first term. So it's a quarter x. We increase the power of 3 and 2 into 5 on 2, and we also now divide it by 5 on 2. And now we integrate the second term as well. So that becomes 3 on 2, x to the, we raise the power of 1, a half, which is 3 on 2, and divided by 3 on 2. Do the same thing for the third term, 2x. If we raise negative a half, we'll get a half, and we divide it also by a half. And then at the end, we must give the x coordinates. So I'll continue this simplification process before I start substituting 2 and 4 in here. I inverted the denominator fraction so that I could multiply it with the numerator. And so I think my final simplification will be this. So frankly, I can use the calculator, but I don't want to, so I'm going to rewrite those powers differently. So I rearranged the x to the power of 5 on 2 as x squared and root x. And the x to the power of 3 on 2 will just become x with root x. And finally, we'll just have 4 and root x. And so starting with 4, I will say that it's 1/10. 4 squared, no, I'll write down 4 squared root 4 minus 4 root 4 plus 4 root 4. And then I'll do the same thing with 2. So it'll be 1/10, 2 squared root 2 minus 2 root 2 and plus 4 root 2. Nice, I can cancel minus 4 root 4 plus root 4, which is now just 32/10, and we will minus this part over here, so that's 4 on 10 is 2 on 5 root 2 minus 2 root 2 plus 4 root 2, and we have nearly finished. Okay, 16 on 5 minus 12 on 5 root 2. Now we do have a negative sign in front, which means that we should now write this as 12/5 root 2 minus 16 on 5. And I believe this is the format that we have to do it in. And yes, I've taken it down, so that means that A is equal to 12/5 and B is equal to minus 16 on 5. And therefore the area is equal to 12 on 5 root 2 minus 16/5. Now these problems are designed for seniors, and this one comes from as exam paper. If you've got problems that you want me to work out for you, I'd be very happy to show you how to do it. Just put it into the comments and I will endeavor to work it out really as fast as I can. And if you appreciated this, please subscribe to my channel, and also make sure you put the thumbs up, because that really helps as well. Now there are a number of playlists in my channel which could be really helpful. There are plenty with integration in it, so just have a look at that playlist on integration.